Hi, I'm Mark Williams. I started detecting in South Australia over 20 years ago. During that time, I've used a variety of Minelab detectors. My first machine was the Eldorado Mark II. I now use the CDX 3030 and the GPZ 7000. Minelab have invited me to take a tour of their new headquarters here at Mawson Lakes. As we go through, we'll be hearing from the engineers about what it takes to develop new products. Phil's the engineering manager here at Minelab, and he's responsible for all new product development. So how long have you been here, Phil?
So I started here in 1998. I started off on big vehicle-mounted array systems for the Army, and then moved on to a GP Extreme as my first gold project. I also worked on Xteras and CTX machines as well.
So how are you finding the new premises and the setup?
We've only been in here for a few months now, but the facilities here are fantastic. We've got some great collaboration spaces, we've got some great meeting spaces, we can get a lot done.
New detectors start with R&D. Lawrence is the R&D manager at Minelab. Let's hear from him. So Lawrence, what's involved in your team's R&D?
We develop tomorrow's metal detectors, and in order to do that we have a core R&D team with 6 people with specialized skills. Many of them have PhD qualifications. For example, we have people who model coils, so they have expertise in electromagnetic modeling. We develop algorithms, and a lot of people specialize in signal processing, and this is a big part of what we do. We have people doing electronics design. We require very precise electronics, so we have both analog and digital engineers.
What are some of the biggest challenges you face?
As you know, Minelab's strength is to make detectors that perform well in real ground conditions. It's relatively easy to make a detector that will detect deep in air, but when it comes to detecting or identifying targets in difficult ground conditions, then it's a completely different problem. How do we go about that? Well, first we have a really good understanding of what grounds look like and what targets look like, but then we do a lot of testing. We develop our algorithms and then we go and test them. We test them first on the lanes because it's convenient, and then we go in real ground conditions in various places in Australia or overseas.
Software is a big part of detectors these days. We've got James here to explain to us a bit more. So what's involved, James?
The detectors themselves generally contain code from C++, but we use a range of other languages to support our development, things like Python and LabVIEW.
So what are the steps that are involved?
The first phase is to gather all the requirements of what the product needs to do. The second phase is the design and development, where we come up with an architecture for the product software and make way for the signal processing algorithms that come out of R&D. So once we've got a detector that will run those algorithms, that can go out for field testing, and then in parallel we'll start developing the user interface and battery management. We'll then have an alpha release, and then that goes on into some testing, come up with a beta release for the manufacturing trial run, and all going well, we have a product release and out it goes to our customers.
Now that we have all this technology, we've got to turn it into a detector. Enter the mechanical team. So Tim, where do you start?
Well, we start off with generating some ideas with sketches, and we take those good ideas, we find which one's the best one. We turn that into CAD models. Those CAD models then get turned into prototypes. We then validate those prototypes, and then from that good information that we've got there, we turn those into production drawings, and then we're ready for production.
So what other tools do you use?
Well, you see here we've got our 3D CAD in SolidWorks, we've got MoldFlow, and a number of other FEA tools. We also use 3D printers and a full workshop where we make real-world models, and that's where we do our testing, such as the mill standard shock and vibration testing, the knock testing, and the wiggle test.
Okay, Phil, so it's obviously a busy place. How do you keep track of everything that's going on?
So we put our project teams together so that the collaboration happens naturally, and over the top of our projects we run a stage gate system that gives a lot of transparency into our projects and lets everybody who are stakeholders in that project see exactly what's going on and when it's going to be due.
We make the world's best metal detection technology.
Currently, of course, we work on new things that we can't wait to have in people's hands.
After today's tour and having a good look around, there's so much more to Minelab than you could possibly imagine.